So, dear students, let's continue with Poisson process. We are going to define it using some example of events which follow Poisson process. For example, you can have random events such as arrival of job at a job shop, or arrival of emails at email server, or arrival of boats to a deck, or arrival of calls to a call center, or breakdown of machine in a large factory. These are events which can follow Poisson distribution, because these events are occurring at a random time in a distributed manner, and we can have a number of events at a specified time. So these events are described by counting function. The counting function is called NT. NT, this is the function, then defined by or t must be greater than 0. It means the time must be greater or equal to 0. So when it equals to 0, it means that at the starting point, this counting function will represent the number of events that occurred in 0 and t time. So it means that or event which occurred between such time. So here the time 0 will indicate the starting point. It means that it is going to indicate the time at which the observation began. It means it is the starting point for each interval in between 0 and t. The value of nt is an observation of random variable which takes the integer 0, 1, 2, and so on. It means that in this interval we can have a 0, 1, 2, t. It means if we have a t equal to 15, it means that we count from 0 to 15. So the counting process NT, where t is greater or equal to 0, we are going to say that it follows a Poisson process, or it follows a Poisson distribution, or it is a Poisson process with mean lambda if the following assumptions are satisfied. It means that we are going to say that the counting process will be a Poisson process if the following conditions are satisfied. Which one? Arrival occur one at a time. It means that no two arrivals or three arrivals occurring at the same time. So it means only one can occur at a time. The second condition is that any t where t is greater or equal to 0 has a stationary increments. It means that the distribution for the number of arrival between t and t plus s. It means that it means that it is the time, for example, at time where at time t is equal to 5, for example, plus s, for example, I can say that I put s equal to 2, so now t plus s will be equal to 5 plus 7. So we can count the number of arrival between 5 and 7 will depend only on the length of interval s. So this will depend on s, not on t. It means that it will depend on the additional time. So not on t. It means that the arrival will be completely at random without lash or slack periods. It means that the arrival must be completely or 100% random. It means that no event will be resembling to the other. It means that they must be different and they coming randomly. So it means that no repetition. So any t where t greater or equal to 0 has independent increment. It means that the number of arrival during an overlapping time interval are independent random variable. It means that those variables are independent. No variable is dependent to another. It means that they are automatically different and independent. So one variable can't affect what type of one variable can't affect the other one. So if they arrive as according to Poisson process satisfying above assumption, if we are having arrivals which satisfy the three assumptions which we saw previously, it can be shown that the probability nt will be equal to n, and then this will be given by pnt equal to n. It means that the probability of events occurring at time t is equal to n. It means that when we are going to have maximum number of event equal to n time n. So here, if we are having this one, it's a formula. How can we calculate this? You calculate this using Euler power minus lambda t multiplied by lambda t power n out of factorial of n for each n going through from 0 to and so on till the end, and the t must be greater or equal to 0. Thus, any t has the Poisson distribution with parameter alpha equal to lambda t. It means that we are having a Poisson distribution which has a parameter alpha which equals to lambda t. So the mean will be the mean will be like this, will be equal to lambda t here. So it means that alpha and the mean are equal. Also the variance is also same. So we are going to have alpha according to mean and the variance. So what are the properties of a Poisson process? If a Poisson process has properties, it has two. Which one? The two properties of a Poisson process which are useful in discrete system. We can have a random splitting and a poured process. Random splitting. If we say splitting, it means separating. There is some thing which was some events or some things which will combined. We can split them and make them apart. And the poured process is the opposite of splitting because you can pour. Pour is means combining. There are some events or some things which were split, and now we combine them. We use the process called pouring process. So random splitting. We have consider a Poisson process having any t where t is greater or equal to 0, having rate which is lambda, as shown in the following figure. We are having a Poisson process. Then we are having the rate of lambda. The rate means that arrival rate. It means that the number of arrival per time period. So we can have random splitting. As I said, it is a process of separating things or events which were combined. We consider a Poisson process any t for t greater or equal to 0. We have a rate which is lambda. So we can represent this using this figure. I'm having lambda. This is a coming rate of the events. So lambda can be split into two parts. The first part will be lambda p The second part will be lambda 1 minus p. It means that the probability, the maximum value of the probability must be 100%, means 1. So you can have the one part xp, this is one part, plus this part. If we take xp and lambda p and lambda 1 minus p, if we add both of them, we will find lambda. It means that if to get lambda, you must have this part plus this one. So this is the opposite of this one, and this is also the opposite of this one. So we spread one event or arrival rate into two parts. So we suppose each event is classified as type 1 event. There can be two types of events, arrival events. Type 1 event with probability p. Type 1 event is with the probability p, and the type 2 event with the probability 1 minus p. So it is the opposite. So this type 1, this is type 2. So let n1t and n2t be the random variable denoting number of type 1 and type 2 events respectively. We are having random variable which can be n1t and n2t. If you add both of them, we find nt. So these are the random variable representing the number of type 1 and type 2 events. One is here in this type of event, type 1 and type 2. So note that the events are occurring, the events are occurring in the interval of 0 and t. And nt must be equal to n1t plus n2t. So the two events n1t and n2t are independent Poisson process having rates lambda p and lambda 1 minus p. This one. So this is understandable. So it means that what we have done, we have a split this event into one type of event and the second type of events. So it will be easy to manage or manipulate this process, because you have separated those two types of events. So you can have also pulled process. To pull the process, it means that combining. It means that consider the opposite situation where a random splitting. This is the opposite situation. Pulling the process is the opposite situation of random splitting. Here, the pulling, we take what we combine what is we spread last time, and we combine them. Here we are having lambda 1 and lambda 2. This is this is event 1, event 2. Then they were separate or separate. Then we combine them. When you combine them, we will find lambda 1 plus lambda 2. So this is pooling. If n1t and n2t are two random variables representing independent, these are independent Poisson process having rate lambda 1 and lambda 2, then nt will be equal to n1t plus n2t. So this is a Poisson process having rate lambda 1 plus lambda 2. So this is what you can have about Poisson distribution. The Poisson distribution, as you saw, you can have two types of processes. You can have a split process and pulled process. And the Poisson process we must have random variables which shows the random events occurring in the interval of 0 and t time. So now we can see about random number generation. Random number are essential part of simulation of almost all discrete system. Most of the programming languages have a built-in function object to generate random number. So here, as you can see, random number. Random number is what is a list of numbers which can be generated, but they have to occur one at a time. But the numbers must be independent. It means that you don't have the same number at the same time. It means that a number 5 can come at this time and will come back after, for example, 1,000 tries. The 1,000 number of it means that I have generated the number 5 now, and then generate so many other numbers, and the number 5 will come back after 1,000 generation. So it means that random number, they will come randomly and no repetition. So for example, in the programming language, as we saw here, in the programming languages, using programming languages, you can generate random number such as in C, C++, in Java. So the random number generation is a very important process because they are used for many situations. For example, you are generating phone numbers. For example, MTN or Airtel are generating phone numbers. Those phone numbers must have 10 digits, for example, in Rwanda. So in order to generate random number, you have to make sure that those numbers will come randomly to assign phone to number, or number to phones. They must come randomly and also independent and no repetition. If there is repetition, it is the same people, also same SIM card will have the same phone number. So this is a very nice example of how to generate a random number. So in the real daily life, random number are used for many situations. Basically, random number are used to generate various random variable. So random number will be used to generate random variables. For example, event time. You can see when the event, at which time an event occurred, or the service time. The service time, for example, customers at a bank. So the time it will be required for a cashier or counter to provide service to the customer. It means it is the duration in which the customer will stay at the counter, so getting the service. Here we will discuss various methods of generating random number, testing for randomness. Here we are going to see how we generate random number, how to test the randomness, and also we can see how to use random number to generate random variable with the help of probability. In order to generate random number, we have to use a probability. The probability, then the various distribution and so on. So what are the properties? What are the characteristics of random numbers? A sequence of random numbers, if we say properties or characteristics, this shows how random number, what are the properties, how we can know if numbers are random or not. So a sequence of random numbers, for example, R1, R2, this is the first random number, this is the second one, must have two statistical properties. So a number to be random, it must have two statistical properties. It must be uniform. It must be uniformity and independence. So uniformity means that they are uniform. Independence means that the next random number does not depend to the previous one. So each random number Ri, if I say Ri, it can be R1, R2, R3, like that, must be an independent sample drawn from a continuous uniform distribution between 0 and 1. So it means that if we pick a random number Ri, it can be, for example, R0 or R2, it can be 5. It must be independent sample drawn from continuous uniform distribution between 0 and 1. It means that if you say between 0 and 1, as we are using probabilities, it means that 1 it is 100%. It means if we are having, for example, 1,000 numbers, so 100% means that 1,000 numbers. So it means that if we pick one number from 1,000 numbers, we are going to call it Ri. It means if I take R0, for example, I am having a 1,000 number, the first number is 1. So R0 is equal to 1. If I put R9 or R10, R10 is equal to 10, like that. R1000 is equal to 1,000. That is, the PDF will be given by fx will be equal to 1 for each, when we are having the counting from 0 and x must be between 0 and 1. It means that, for example, if we are having 1,000 number, x must be equal, the number must be between 0 and 1,000, like that. 1,000 is 100%, so it is like 1 here. So if x will be equal to 1 if x is in this range, otherwise it will be equal to 0. So the density function is shown in the following figure. Density function, for example, I am having 0, 1 and x. So no, not 1, it is 0, x. So x is going from 0 and it will continue. That means when we are having x is equal to 0, if x is equal to 1, when, for example, x is equal to 1, fx will be equal to 1 because it is in the range of 0 and 1. If here I put x is equal to 2, 2 is out of 1, is out of range. So as 2 is greater than 1, fx will be equal to 0. So fx will be here. It will be equal to x, it will be here. No, x will be equal to 0, it means here. So it is nothing. So only the number which make fx range in this zone are valid. Others are invalid. So the range must be between 0 and 1 only. So the expectation of random number, expectation or the mean of a random number Ri, it can be R0. For example, R0 is 5. So the expectation of random number Ri will be 2. So the expectation of random number Ri will be equal to integral going from 0 to 1 x dx. See, this is the formula. So we are having, it must be in the interval 0 and 1. So this formula, according to the formula, this is the formula, the integral formula, you know it. If you are having x here, it will be, we have to increase the power. The power of x, we will have to add 1. So here it is having a power 1. So if I if you add 1, it will be equal to 2, and then the power must go to the denominator. So integral of x dx, it gives this one, gives x power 2 out of 2. So in the range of 0 and 1. So here, if you have this one, it means you have to replace first by the upper board, and then replaced by the lower one. So we start from replacing x by 1. So if I replace x by 1, I will have 1 power 2 out of 2 minus x replaced by the lower bound. It means that 0 power 2 out of 2, this one. So here I am going to have 1 out of 2. So this is half. The variance will be equal to what? Will be equal to expectation of r power 2 minus expectation of r power 2. This is different. So we are having expectation of r power 2 and expectation of r power 2. This is different. So if we do this one, this is equal to this integral, this one. This is this function to power 2 here minus this one. It is what you got here, 1 out of 2 power 2. So the result will be like this. As you saw, the power must be added by 1, so here it will be 3 out of 3. So I am going to have x power 3 out of 3 in the range of 0 and 1 minus 1 out of 4 here. So this will be equal to what? This will be equal 1 3 1. X is replaced by 1, so it is 1 out of 3. If we replace it by 0, this will give 0, this one minus this one. So we are going to find 1 out of 12. This is variance. So now we are going to see how to generate a pseudo random number. If we say pseudo, it is like something which is not true, which is not real. For example, if they say pseudo pastor, this is a pastor who is not a real pastor. If they say pseudo human being, it means it is not a human being. It means it pretends. If we say pseudo code, it means that these are codes which are not real code. It means they are not entered into the computer. They must be drawn on the sheets of papers. So here we can generate pseudo random numbers. How to generate them? We can use we can have different methods to generate random numbers. These methods we know already this method, but the term random sometimes is not exactly mean what it indicates. That is why we have to put pseudo random. So instead of using the term random number, we can use the term pseudo random. So the goal of any random number generation scheme is to produce a sequence of numbers between 0 and 1. So the purpose of generating the random number is to produce numbers between 0 and 1. If we say 0 and 1, it doesn't mean that those numbers are really between 0 and 1. As I said previously, 1 is the probability, the maximum value of the probabilistic number is 100%, which is equal to 1. It means that these numbers must be in the range of between 0 and 1. Otherwise, our function will be equal to 0. So this must be initiate uniform distribution. So in the generation of random number, certain problem may occur. When you are originating random numbers, some problem may occur. Which one? Generated number may not be uniformly distributed. It means that generated number may not be uniformly distributed. They are not distributed uniformly. So they are distributed uniformly, different. So this is a problem. It means that there is no sequence of production of such a number. So generated number also may be discrete instead of continuous. It means that sometimes you may have some changes. Also, the mean can be too low or too high. If the mean is too low and too high, it is a problem. So the mean must be an average, in the middle. Also, we can have the variance. The variance of the number, the variance of such numbers can be too low and too high. If we are having a mean which is too low or too high, it means also the variance will be too low and too high. This is a very big problem. There may be also some dependencies due to autocorrelation. If we say autocorrelation, it means that there will be some dependence. It means that when one number which is autocorrelated to another number changes, its method also can change accordingly. So this is a problem also. We have several methods to generate random numbers using a computer with the following condition. You can have different methods to generate random number using a computer, but they must be some condition. Which one? The condition should be that that method used to generate random number should be fast. If it is slow, it is a problem. For example, if we want to generate 1 million phone number, if it is not fast, it will be a problem. So the method also have to be portable to different computer and to different programming languages. If you are using a method, the method should be able to such algorithm must be able to be used by different programming languages and computers. So it means that if any language you are using can use such method. So such method is very nice to use when you are generating a random number. The method should have sufficient long cycle. It means that now random number generated may start repeating from one sequence to the other sequence. There must be enough gap. Here, what we mean is that when you generate random number, for example, now 5, so there should be a very long cycle or a very long repetition in order that the number 5 should come again or should repeat. It means that if you are having a random number, so if you generate the same random number in the future, there should be a very long gap. For example, if I generate a random number using phone numbers, if I generate a phone number now, so using a program, so the phone number generation should repeat after, for example, 10 years. After 10 years, maybe the person who was getting such number, phone number, maybe he went out of the country, for example. So that phone number is no longer active. So I can regenerate it, but after a long time. If you generate it very sooner, the phone number is still active, so it is not good. So there will be some duplication, but it is not allowed. So the random number should be repeatable, independent of the system which generated it. It means that you have to be able to generate random number without the system does not highly affect the number. It means that the random number generated are independent from the system. If they are dependent to the system, it means that the system, if there are some changes in the system, this can affect also the random number, so they will change. Generated random number should closely approximate the statistical property of uniformity and independence. It means that they must be uniform. For example, you are generating a phone number of 10 digits. It means that all phone number you will generate in the future, they must be of 10 digits. For example, you see, if you are using M10 phone number, they must have 10 digits. So, for example, in the future, you generate the random number of M10 and put 9 digits. You see, that phone number is not valid in Rwanda. So, there must be some uniformity and independence. Independence means that the phone number you generate now is different or is dependent from the phone number you generate tomorrow. So, here you can have some techniques of generating random numbers. So which one? The first one is the linear congruential method. So the linear congruential method produces a sequence of integer. We produce the integers x1, x2, x3, xn. For example, 1, 2, 3, 4, and so on. So there's a number between 0 and m minus 1. So I am generating a number from 0 to m minus 1. If I start from 1, I am having 2, 1, and m. So as I start from 0, I must put m minus 1. So I use which formula? This one. This is the method. Xi plus 1 will be equal to a multiply xi plus c mod m. For I going from 0 to and so on. So it means that here the initial value x0, it will be called a seed. A seed means that it is where we start. So we start, the starting point is a seed, and then we are going to apply different variable and the value and the constants to it, and the number produced will change. So here I will be called a multiplier. It is used to multiply. It means that to change. It will help us to change the value for the random number. The C also is increment. It means that to increment, it means that we increment the generation of random number going from start till the end. And M is the modulus. This modulus meaning that this modulus will help us to put some randomness. So if C, it means that the constant which is increment is different from 0 in this equation. It means that then it is called as mixed congruential method. If C is equal to 0, then it is known as a multiplicative congruential method. It is multiplicative because it is different from 0. It means that its value will make our generated value change. So the selection of the value of A, C, M, and X0 drastically affects the statistical property and the cycle length. According what you choose here will affect the whole system. It means that statistical properties, it means the mean and the variance will change, and the cycle length. Cycle length means that how the repetition is going on. So we note that using the above equation, random integers are generated. Using this equation, we are able to generate random integers. But the requirement is a random number in the range of 0 to 1. So what is the purpose? Our purpose is to generate random number in between 0 and 1. So how to calculate them? We calculate them using this formula. We say random number Ri or R0 or I5 R5 will be equal to X5 divided by M. But I must go from 1, 3 till n. This is equation 2. So let's see an example how to generate random number. Example: use the linear congruential method to generate a sequence of random number if x0. This is the seed 27. A equal to 17. This is the multiplicative. Then C, this is the constant 43, and the M modulus is 100. So what is the solution? Here the sequence of cities xi and the subsequent random number Ri are computed as shown. X0 is 27. X1 will be equal to what? Will be equal to A according to the formula A multiplied by X0 plus C mod M. So A is 17 as we are having in the question. X0 is 27, which is here. Then plus C, which is 43 mod 100. So if we take this, we add this with this, and take modulus 100, we get 2. So the modulus is what? It is the remainder of the division. So we take the summation of this and divide by 100. So the remainder will be 2. Now R1 will be equal to what? It will be equal to Xi according to the formula Xi divided by M. So it means that Ri, it means that the random number, the second random number is equal to 2. It means Xi, which is which is Xi is equal to 2. It means that Ri, the first random number will be equal to 2 Xi1 divided by M. M is 100. We are going to see that the next random number is 0.02, like this. This is the random number. So this is invalid because it is in the range of 0 and 1. So X2, the same formula. We are going to have A is 17 always. Xi is 2. This one 2 plus C 23 mod 100. So we are going to have a 77. So we take R2 will be equal to X2, which is 77 divided by 100 M. We are going to have 0.77. X3 it will be 53. If you calculate using the same formula, we are going to see that it is 0.52. You can calculate it till the end. So you can continue in the above manner. You can generate as many random numbers as required. So you can generate any number of ones. Here there is another example. Generate random numbers using a linear congruential method. X0 is 23, A80, C47, and M100. So Xi plus 1 must be equal to Xi plus C mod M, the same formula. X1 will be equal to 8. This is A. Xi 23, which is means X0, the previous value of X, plus 47. 47 is the C mod 100. So if we do this, we will find that one. If we take Xi, if Xi is 31, the random number, the first random number Ri will be Xi divided by M. It means that 31 divided by 100, we are going to have 0.31. So R1 is equal to 0.31. You continue like this. We have for X2 will be 8 multiplied by XR 31 plus 47 mod 100, we got this one, and the x2 will be 95. So the R2, the random number, the second normal number generated is 0.95. We can continue till the end. So this is how you can do. You can generate as many random numbers as you want. So here the same procedure. Here we generated the random number till R5, which is 0.71. So using this formula, you can generate different random number as many as you want. So this is useful in many situations. So dear students, till now we finish our unit 2. Then next we will be seeing the unit 3, which consists of queuing models. As people working in the bank, they know they have to think about queuing model about the customers. So the customer must be put into queue in order to get services. You can't serve all people at the same time. So that is why queuing model are very important. So we will see how they are useful in many situations. Okay, thank you.